In this video, we're going to answer this interesting Math Olympiad question. Okay, so how do we handle this question? So this question is coming from our understanding of indices, okay, and of course quadratics. So if you look at this question, it's basically very complicated for you to handle it as it appears as an equation. So, but one thing that you're able to see is, at least we understand that the 9 that we have can be expressed in a different way. So we understand 9 is the same as 3 to the power 2, right? So now the 9 was raised to the power x. So minus 3 to the power x equal to 6. At that stage, things look a bit simpler. So we have 2 times the power there. 2 times x is 2x minus 3 to the power x, which is equal to 6. Now, the one thing that we can see here is, for the first part, we have 3 to the power 2x. So we can write it as 3 to the power x. So I can pull out the 2. So we understand that that's the same as the power 2x. That's a product of x and the 2. Now, the reason why we're doing that is we want it to appear identical with the minus 3x equal to 6. Now, at that point, since we can see that the 3x and the 3x are common, to make it easier, we can let that be equivalent to, let's say, y. So let y be equal to 3x, 3 to the power x, that is. So we can have y to the power 2. So at every point where we have the 3 to the power x, we are putting y. So we have minus y. So that already appears as what? As a quadratic function. We can now simplify it. So at this point, I believe things are easier. So you know how to solve quadratics. You can feel free to pause the video and answer it. So if a 6 goes the other side, it becomes a negative, now equal to 0. So quickly, what do we have? So the product in this case is 1 times the negative 6. The product is negative 6. The sum is negative 1. What two numbers can you multiply to give you that? And add them to give you a negative 1. So 3, negative 3, and a 2. So therefore, we understand that after factorizing, we are going to have y minus 3 and then y plus 2 is equal to 0. So that implies our solutions for y is equal to 3 and then y is negative 2. Now the question didn't give us any y. The question gave us 3 to the power x. 3 to the power x. Take note of that. So therefore, where is y? So let 3x be equal to, the first result was 3. Now in such a case, we can clearly see that the value of x now becomes what? So x is equal to 1 in the first case. Now, considering the other case, you have 3 to the power x being equal to a negative 2. Now, you can't solve that one using indices. So you've got no option but to apply what? Logarithms, right? So it becomes x log 3. And then the other side as well, you have what? You have log of minus 2. It's like I've forgotten my math. I don't know if it's possible for it to determine the log of a minus 2. But of course, for Olympiad cases, you can just say your x is log, because calculators are not allowed, divided by log 3. So you can end at that point. So that's how you basically get to approach this question, by applying the rules of indices.